Alright, let's talk about an algorithm to solve the stable matching problem. So I'm calling it pick and reject to match my martial artists and weapons example I was using in my previous, but this algorithm is commonly called propose and reject, and officially it's known as the Gale-Shapley algorithm. So, just as a quick refresher, my version of the example is, you have some martial artists and you have some weapons, and we want to make pairings between these two. So let's look at the pseudocode. So in this pick-reject algorithm, we have an input of two matrices of size n by n of the preferences of both groups, right? We have the preferences of the martial artists, and we have the preferences of the weapons. And your output is going to be one n-element array of the pairs of the martial artists and the weapons. So first, we initialize everybody as free initially. And while any given martial artist is free and has not picked every weapon, we're going to choose one of the martial artists, and we're going to set that martial artist's weapon as the first weapon that has not been picked yet. So in this algorithm, I should have said this earlier, but in this algorithm, how it works is we first, because we're the humans, right? We're going to have the martial artists be the ones who will be picking the weapons. And if the weapon does not have a current wielder, they are not allowed to say no. So they have to accept the person who picks them, to be their wielder. But if they have a second person who comes along and says, hey, can I be your wielder? And they like that person better than their current wielder, they are allowed to say, yeah, I'm going to reject the person I have currently, and I'm going to be matched with the new person. All right, so where were we? Yes. So we're going to assign the pair like this, and that is if the weapon does not have a current wielder. If the weapon does have a current wielder, if the weapon prefers that person to their current wielder, then of course, they can just make the new pairing with the new person, or else they can just reject the person. Alright, so let's run this through once to see how it works, because obviously with this kind of thing, it's much easier after you see it in action than just randomly yapping about it. Alright. So a lot of these kinds of algorithms are actually quite vague, right? We'll talk about implementation details later, but for now, it does not matter which one we start off with. So, like I mentioned, it's quite vague. This is basically just the gist of the, pick and reject, or propose and reject, or Gale-Shapley algorithm. So let's start off with Z here. Because Z has no weapon right now, we can go back to her preference list. All right, let's look at Z's preference. Z prefers A, the axe. So we can pair them up right now. All right, so they're paired and they're happy. Now let's look at the next one. Let's go with Y. Y wants to be paired with the bow. All right, great. Now let's look at X. X prefers A. So X will go along, right, because we're looking at the first weapon. So X is going to ask, hey, Axe, do you want to pair up? And then Axe, because Axe already has a wielder, Axe is like, let's see. Oh, will you look at that? Axe prefers Y over Z. So Axe will break this arrangement, and then Axe will choose X as its wielder, and so on and so forth. Now, let's look at a slightly larger problem. So for this example, we have 2 more people and we have 2 more weapons. It's like, the dagger, and what else? So let's run this algorithm through and see how we solve it. Because if we're given a 5x5, it's a bit harder to just do what we did earlier and kind of just like eyeball it, right? So let's see how this algorithm works. All right, we're going to start off with person V. So person V, right now, everyone is initialized as free. So person V is going to ask, hey Axe, do you have a wielder? Obviously Axe does not have a wielder, so we're going to pair person V and weapon A, anyways the axe, right? So I'm going to write a little chart here, V, W, X, Y, Z. So anyways, these 2 are paired right now, right? And then we can do the same, right? Bow has nobody yet, club has nobody yet, dagger has nobody yet. So all of these, pretty normal, right? Pretty standard, pretty boring. However, when we get to Z, Z wants the axe, right? I still have pictures, yay! Okay, Z wants the axe, but currently the axe is with V. But if we look at the axe's preferences, Axe prefers Z over V. It's not, it's not one of its favorites, right? Like Z isn't one of the Axe's favorites, but Axe still prefers Z over V regardless. So Axe is going to say, hey, I'm going to break my engagement with V, and I'm going to become Z's weapon. So now they are more happy than before, because Z now has a weapon, and the axe now has a wielder. It prefers a little bit more than V. So now they are paired. So V is no more with A, right? It's not wielding the axe anymore. So V will go on to their next preferred weapon, which is the bow. Yippee! The bow. However, the bow currently has a wielder already, right? The bow's wielder is actually W. Oops, I don't have a W. Anyways, yes, the bow's wielder is currently W. But if we look at the bow, does bow prefer V over W, right? Let's look at this. And the answer is yes. Bow does prefer V over W. So now bow will break this engagement, and bow is now paired together with W. So now I'm going to also circle this side to make it a little bit more clear who is paired with who. All right, so V and B, right? So that is V. And then W is currently pairless, weaponless. X is paired with C. And then Y is paired with D. And then Z is paired with A. Now that W is weaponless, W will go on to the next weapon on the list, which is C. So we can go back to the club and see, okay, W asks club, hey, do you want to be my weapon? And then club is like, well, I like W over person X. So I'm going to break my arrangement with X. I'm going to become W's weapon. And W is also happy because now they are wielding the club, which is the second favorite weapon of W. And we can continue this process. So let's look at X, right? X no longer wields the club. X moves on to D, right? Let's see, D. Does D like X better than Y? Yay, X and Y. And the answer is yes, D does like X better than Y. So bye-bye Y, X, and then D and X are now paired together. And we can keep on asking and keep on moving forward with this algorithm. So y goes to D. Let's see. D? Ask D. Does D prefer... Oops, my bad. It moves on to A, the axe. And the axe is right here. Yay! Alright. So Y is like, hey axe, do you want to be my weapon? And of course the axe prefers Y over Z right here. So the axe will break its arrangement with Z and then go with Y. And now Z is weaponless. So now Z will ask Bo, hey, do you want to be my weapon? And then Bo, because Bo prefers Z over V, it will break the arrangement with V and go with Z instead. Like this. And now V is back to being weaponless. So, no more weapon. We'll move on to C. C, C. Alright. C, better than W. So now these two are together. Right, W. We X out the W. And then W is no longer with C. So we'll move on to D. D. Alright. D and V. D and W. D definitely prefers W to X. So it'll break the arrangement with X. Go with W instead. Now these two are together. Now this guy. X. X has no weapon. So now X will move on to A. Here. And then, let's see, A. And A does prefer, the axe does prefer X over Y. And this guy is crying now. So, it'll break with Y and go with X. Now X move on to Bo. Let's see. And Bo prefers Y better than Z, so Z has no more. And so Z has to ask Club if Club wants to be her weapon. And Club, because Club prefers Z over V, Club will accept. And Z will be paired with a club. And V will be weaponless. Now V goes to ask D. D, hey Dagger, do you want to be my weapon? And Dagger prefers V to W. So Dagger will shuffle up. And now there we go. And then now W has no weapon. Now we go back to asking Axe if Axe wants to be W's weapon. And oh wow, what do we have here? Axe is now with its favorite person. So Axe is a very happy Axe. Look at this happy Axe. It's a smiley face. So Axe is now with W. And no one with X. So X can't do that anymore. X will ask Bo now. And Bo will definitely accept because X is Bo's favorite, right? So now these two are paired together. And then this leaves Y, weaponless. Y is crying yet again. So Y will go ask the Club. Club really likes Y, so Club is very happy now. And now Z is weaponless once more. So Z will go back to asking Dagger. And D likes Z better than V. So now V has no more weapon. And Z is paired with D. And then V is all the way to E. I don't know why nobody likes E, but hey, V will ask E. And E, because, it's the first time anybody's asking anybody's asking E, E will definitely accept. And, it just so happens that E's favorite is V. And there we have it. So the answer, after running the pick and reject, or the GS algorithm, right? GS algorithm is this. So we have VE, WA, XB, YC, and ZD. Now, if you observe what just happened, right, we see that the people, like the martial artists, they start off with their preferred choice. So they go in descending order, while the weapons, right, they are never unmatched. Once they have a wielder, they will never not have a wielder. So they will keep on going in ascending order. They will always trade up, right? They will never become unmatched after they already have a match. All right, so as we can see in this case, we had to do a lot of swapping, right? There were a lot of unhappy martial artists and a lot of, weapon swapping. So in this case, in the worst case, we would need a runtime of n squared. So in the next one, we will do a proof of this algorithm to make sure, it actually works. And we'll talk a bit more about this as well. Thanks for watching, and see you in the next one!